In this video, we were going to continue talking about section 14.1, and we are going to start graphing y equals tangent of x. So this function, its graph is a little bit different than the sine, which looks like this. That's one period of the sine, and cosine, which one period looks like this. All right, instead of having all real numbers and having these maxes and mins, as you can see from this graph, it continues going all the way up and all the way down, so it's not going to have the maximum and minimums like we did on the sine and cosine graphs. Alright, so reading through some of the characteristics, the domain is still all real numbers, except for the odd multiples of pi over 2. So if I look on this graph at pi over 2, I can see that I have this dotted line. And that is what is called an asymptote. So an asymptote is a line, kind of a boundary line, that our graph is going to approach. So as this graph keeps going up, it's going to get closer and closer to that boundary line there, but it is never going to cross it. And then as soon as I cross it, I'm all the way down here at negative infinity. Alright, so it's just a nice boundary line to draw in to, help us draw it out fully. Alright, so the range is all real numbers because it shoots all the way up and down to positive and negative infinity. So our graph here does not have a maximum or minimum. Now, one thing that I want you to note, as far as it doesn't have a maximum and minimum, that means when you draw it, it is not going to look like this. Alright, it's not going to have those humps and bumps, those peaks and valleys in there. It is a smooth curve. From that center, it goes up and it goes down. There is not really, a peak and a valley there, no vertices. And characteristic number 3, it does have a period of pi. So the pi distance, if you're looking on a graphing calculator, it's going to be just past 3. At about 3.14 is when it starts to repeat. So if I were to start here at 0, it goes up, hits that asymptote, and then I've got to come up from negative infinity, and that's when it starts to repeat there at pi. And number 4, the x-intercepts occur at starting at 0 and then every pi units. Alright, and that is just for y equals tangent of x. As soon as we add in some values here, that's going to change my graph a little bit. Alright, so let's go ahead and look at an example. Alright, so as you can see in this example, we've added in 2 and we've added in 3 in the a and b places. So we need to make sure, we know what that a and that b is doing. So if we go back here and look at our characteristics, I still have that a and b, and the b is still going to help me determine my period. However, here, notice that for tangent, a period is not going to occur every 2 pi, it is every pi units. So instead of it being 2 pi over b, for tangent, it is pi over the absolute value of b. And then the vertical asymptotes are at odd multiples of pi over 2 times the absolute value of b. Alright, so that's going to help me figure out how often my curve, my function is repeating, and where to place these asymptotes. So if you look at this graph, and you're looking at one period, keeping in mind I'm going from on both the negative and positive sides of that y-axis instead of starting here and then going across an asymptote. Alright, so I have one smooth curve here. I do have that center right there at my origin, and I take my period, whatever my period is after I compute it, and I chop it into fourths. Alright, so dividing it halfway to the y-axis there, and I have a point here, so whatever that a value is, when I chop up my period, I'm actually going to get a nice point to graph there. So that is that a value. Alright, so this is a couple of the important points that we're going to look at. You're going to plot those points. You're going to find the period first, and that's how we're going to go about attacking these problems. Alright, so looking back at that first example, graph one period of the function 2 tangent of 3x. So b here, b is 3 and a is 2, and those are going to play some valuable parts in our graph. Alright, so in order to tackle this, first I want to figure out what my period is. So the period is pi over b, or pi over 3 in this case. And my intercepts are going to occur at 0, 0. My asymptotes, I calculate that with this formula, pi over 2b. So my asymptotes occur at multiples of pi over 6 here. Which means it also occurs at negative pi over 6. And then I compute those halfway points. So what I do is I take, these pi over 6, the pi over 2b, and I divide that by 2. And that is how I get that pi over 12, comma a. And I do that on the negative side as well for a nice graph that looks like this. Alright, so it's important that we end up getting, that center point. I do want to draw in my asymptotes, chop that in half, and then get that point, comma the a value. Alright, and it is important, for sure, 100%, to mark your x-axis. Alright, these graphs are not going to be accurate at all if I don't know what you guys are taking your steps by. So it's important to label. Okay, so here's some guided practice. For this one, you first want to, find your a value, find your b value, compute the period, chop it up, draw in those asymptotes, and then find those critical points. Alright, so if you pause the video, see if you get a graph that matches the solution. Alright, and one final note here after your last guided practice. It is possible, so I'm just going to draw in a general tangent. Alright, so this is just what I would call one period of the tangent. Alright, if it were, so let me go ahead and label this f of x equals tangent of x. If I went ahead and made this g of x negative tangent of x. Alright, what this is going to do to my graph is it's going to conduct a reflection. Alright, so instead of it going up on the right side of the graph, it's going to be going up to the left on the left side of the graph. And that's what's going to happen. So they maintain the same properties as far as, your period and those x-intercepts, and as far as the asymptotes and everything are concerned. It's just going to look a little bit flipped. Alright, if you guys have any questions, feel free to send me an email. Good luck!